everybody, hopefully you're ready for our last topic of discussion in the measurement unit. We are going to talk about density. And you see the cool little question at the top of your note guide there, so you can think about that. Which one's heavier, pound of lead, pound of feathers? Think about that for a moment, and hopefully you recognize that while it may seem like feathers are a lot lighter, we are told we have a pound of both. So we have the same weight of both of those, which means we must have a different volume of those two things, right? We have a whole heck of a lot less lead than we have of feathers, but they both weigh the same amount. And while we're on the discussion of weight, we should really distinguish between the idea of mass, which is really the amount of matter of something, the amount of matter within something, versus weight. Weight is the gravitational pull on that matter. So how hard is gravity pulling down? When you get to physics, perhaps next year, you'll realize that force is equal to a mass times acceleration. So our mass is our mass, and the acceleration is due to gravity to give us the force, which is weight. So basically, your weight changes whether you're on planet Earth or somewhere like the moon, but your mass never changes. That's how much stuff is in you. So let's try plugging in some density problems. We have some different tips down here as to how you could solve things, but I think you'll see these come to light whenever we actually solve the equations. Just remember that in general, density is equal to a mass, we'll call that M, over volume. And so as long as you have a mass over volume, you should be good to go, unless we ask you to change around those units. So in number one, we are asked, what is the density of a block of marble that occupies 310 cubic centimeters? Cubic centimeters we know is a volume. And it says we have a mass of 853 grams. And you'll notice that we're not asked to do anything special with units. So because we have a mass and we have a volume, we might as well leave those alone. And so we know that density is equal to mass divided by volume. And let's go ahead and let's plug those in. So our mass is 853 grams. We said our volume is 310 centimeters cubed. And if you go ahead and you do that math, you do the calculation, you'll end up with 2.75 grams per cubic centimeter. So basically how much stuff there is per unit volume, 2.75 grams for every cubic centimeter. Let's talk sig figs briefly. You'll notice the 853, this has 3 sig figs. The 310 has a tricky little decimal point, so that decimal point makes that trailing 0 significant. That has 3 sig figs. We're doing division here, so 3 over 3. 3 is, the same number of sig figs as 3, so that means our answer has to have 3. There's not one that has fewer sig figs for us to worry about. Let's look down at number 2. In number 2, you'll notice that a density is given. Density being given in a problem is a red flag that you want to use this as a conversion factor. So we are after, ultimately in this problem, we are interested in the mass, and we're given a volume. And the volume in this case is 0.351 cubic centimeters. So we're going to start with the number that's given to us, and we're going to use dimensional analysis. We have 0.351 cubic centimeters. We'd like to convert that to a mass, and it turns out that our density is our little trick for converting from a volume to a mass, because we know from dimensional analysis we need to have cubic centimeters on the bottom to cancel. And you'll notice that pink number up there tells you the number of grams, aka a mass. There's 3.26 of them for every 1 cubic centimeter. Your units cancel, you do the math. If you do this one, you'll end up with 1.14 grams as your final mass. And you'll notice in the problem that we were given some numbers. We were given this density that has 3 sig figs. We were given this volume that has 3 sig figs. They both have 3, therefore our answer should also have 3. In number 3, we're asked in this case for a volume. We are told that we have a given mass. And again, we are told that we have a given density. density red flag, we're going to use that as a conversion factor. So let's start with the number that we're given. We're given 76.2 grams. We know that we need to put grams in the denominator of the next fraction in order to cancel out. We are ultimately trying to find a volume, and so volume is milliliters. Do we have a way of getting from grams to milliliters? Well, of course we do, because we have this density right here, which tells us that for every 1 milliliter, we have 13.6 grams. Our grams cancel because we have one on the top, one on the bottom. Do this math, you will get 5.60. And we have milliliters as our uncrossed out unit, so we're going to keep that as our final unit. You'll notice that we started with 3 sig figs and 3 sig figs. If we have 2 starting values both with 3 sig figs, therefore our answer must also have 3 sig figs, and we are good to go.